Okay. Good afternoon to all. So see, the strength is again very less. Your class is at 12:30, and you're joining 12:35, 40 like this. Right. Uh, so yesterday we discussed some questions regarding your mid-one examination, and uh, question number, I think we were discussing question number five, five I think. So 5.6 we'll discuss today. That is about Hamming code, and if the data is received in is incorrect, how to do the correction. That also we'll discuss. Question number 6. Okay. So before that, uh, one topic left, that is from your module 1, that is signed magnitude representation. Actually this topic is not mentioned there in the module 1, but in other sections it is covered, right? So we also cover up this one. So your question number 2 is about subtraction, right? Subtraction using ones complement, subtraction using nines complement, and also subtraction using xx3 in nines complement. So these things we'll discuss through this topic, right? That is signed magnitude representation. And in the starting class, I remember uh, one student asked me about the negative binary numbers, right? If a binary number is negative, then how to represent that number? So that thing will be covered in this topic. Okay, how to represent the binary negative numbers, or how to represent a negative number in binary system. Okay, so already we know about the binary system, right? So today we'll discuss about the signed binary numbers. Okay, see, okay, we'll discuss about the signed. This topic is obviously important for you. So we'll discuss. Where the main topic name is its name is signed binary system, right? Right, the topic name is signed binary system. Means how to assign a sign, means how to assign positive or negative sign to a binary system. So obviously this is different from that binary system. The binary system we discussed, in that there was no negative sign, right? Only we are we discussed about the positive numbers only, right? But in this signed binary system, here we have the option for negative binary number also, right? If question will come, it will be mentioned in the question. Represent this in signed number, binary system or number like this. It will be mentioned in the question, right? If it is not mentioned in the question, then you have to go through that we discussed previously in module 1, that is binary system only. There was no negative sign. But especially in the question, if it is mentioned, represent this number in signed binary system, then you need to follow all the rules that we are going to discuss in this topic. Okay. So signed binary system means here we have the option to provide a sign, that is either positive sign or negative sign to a binary number. How? Right. So, okay. Positive, right. So we know in decimal number system, we know plus symbol, it is used for positive. If the number is positive, then we use positive symbol, right? And this negative symbol is used if the number is negative. Okay. In the binary system or in the signed binary system, this positive is denoted by 0. Remember, right? 0 means is a positive, right? So if the the MSB bit, right? We know about MSB, right? LSB, least significant bit, and MSB is the most significant bit. So in signed binary system, this MSB bit is the sign bit, right? The MSB bit is known as the sign bit, is known as sign bit. Okay. So based on the MSB value, we can say whether it is positive binary number or negative binary number. If the MSB bit is 0, then it is positive binary number. If the MSB bit is 1, right? If the MSB bit is 1, then it is known as negative binary number. Understood? Right. We'll take some examples. Okay. So how to represent the negative binary numbers? We have three representation. Okay. How to represent the negative numbers? We have three representation. So what are the representations? Okay. So we'll discuss. First one is here. You can see on the screen, that is the signed magnitude representation. First one is this is the first one. Okay. This is the first one. This is the first one, is the signed magnitude representation. Okay. Whatever we discuss now, that is 0 means positive, 1 means negative. Right. Right. In this signed magnitude representation, this is the case. Right. 0 means positive, 1 means negative. Okay. Another representation is there, that is one's complement representation. Right. One's complement representation to represent the negative numbers, negative binary numbers, right? Already we have discussed how to find out the ones complement of any number, any binary number. So ones complement and twos complement both are related to which number? Binary number, just remember, right? And next complement is seven's complement and eight's complement, they are related to octal number. Okay. 15th complement and 16th complement, they are related to hexadecimal number system. Okay. And 9th complement and 10th complement, they are related to decimal number system. These things already we discussed in the previous classes, right? So when the case binary number system will come, then it is related with ones complement and twos complement. So by using this two type of complement, we can represent a negative number. How? Okay. So second representation is ones complement, and we have a third representation also. So what is representation means how to represent a negative number, negative binary number. Another representation is twos complement, right? These are the three ways we can represent a negative number, right? It will be mentioned in the question. In question number 2 also you have seen that question is written, find this number minus this number using 2's complement, find this number minus this number using 9's complement. So it will be mentioned in the question. Why? Because for all the complements, rules are different. There are so many rules. You have to remember the rules step by step, right? So we'll discuss about these rules. If it is one's complement, how? So like this. Okay, understood? So we have three representation to represent a binary number: signed magnitude, ones complement, and two's complement. So what is the difference between these three? Right, we'll discuss. So first of all, signed magnitude representation. Right, we are discussing signed magnitude representation. So in signed magnitude representation, suppose question is find out the value of or represent the decimal number -5. Represent the decimal number -5 in signed magnitude representation. Understood question? Question is represent the number -5 in signed magnitude representation. Okay, so how to do this one? So first of all, we'll find out what is +5, right? What is +5? We'll find out first. Then we'll go for -5. Okay, so +5 is a decimal number also, right? Is a decimal number also. So how to represent? See, MSB bit, just leave the MSB bit, right? Leave this bit, right? And here plus is written means I should write here MSB bit is 0, right? And 5, what is the binary equivalent of 5? Is a 101. Yes or no? 101. So this is the answer. Understood? For any doubt? +5. Plus means MSB bit is 0 and the number is 5. 5 means binary conversion is 101. So the +5 binary conversion is 0101. Right? Then -5. So you can do easily. So MSB bit will be minus means it will be 1. Right? 1. Then what is the magnitude? Magnitude is 5. So 101. Understood? So this is not the case in binary system. This is different case. This is in signed magnitude representation. Understood? Rules are different in this topic. Okay. So understood? Understood? So we'll take another example. Let it's 10. Right? So +10 -10. First of all, what is the sign? Is a plus sign. Okay. Plus means MSB bit will be 0. Right? And what is 10? Binary equivalent of 10 is 1010. So just write down 1010. So this is the answer. If it is -10, it's a 11010. Understood? Or any doubt in signed magnitude representation? Some of your friend asked me about this negative binary number. Okay, understood? This is the signed magnitude representation. Okay, next we'll move to your ones complement representation. Okay, any doubt in this? Shall I move? Right? Okay. Okay. Next is ones complement. Okay, ones complement representation. Complement representation. Okay, ones complement representation. So in ones complement representation, suppose question is represent -5, right? Represent -5 in ones complement representation. So what would be your answer? So first of all, you need to write +5. Okay, so you have to apply the same rule as signed magnitude. +5 means it is 0101. Okay, this is +5. Okay, what about -5? You have to take the ones complement of +5. Right? Understood? -5 means you have to take ones complement of +5. So it will be -5. This is the rule for this ones complement representation. Right? So its answer -5. Answer will be, so you have to just, it will be 1 0 1 0. So this is the answer. It is different in signed magnitude representation. Here it is different. So what you have to do? What we have to do? We have to take ones complement only. In order to, if you want to do the sign change. Understood? So in the same manner, if +7 is known, what is +7? It's a 0 1 1 1, right? So what is minus 7? It is equal to, just take 1's complement. So it will be 1, 0, 0, 0. This is minus 7. Understood how to represent negative numbers in 1's complement? Right? Okay. Next is 2's complement representation. Same, right? 2's complement representation. Right? It's a 2's complement representation. Same thing. Plus 5. If plus 5 is 0, 1, 0, 1, then what is minus 5? Minus 5 will be, you have to take 2's complement. Right? You have to take 2's complement. So what is 2's complement of 0, 1, 0, 1? 2's complement of 0, 1, 0, 1 is, first of all, we have to take 1's complement, then plus 1. Right? 2's complement is nothing but 1's complement plus 1. Or we have a shortcut method also discussed in the class. Right? So I'll take 1's complement, then I'll add 1. Okay. So it will be 1, 0, 1, 0 plus 1. Understood? Take 1's complement, then add 1. Okay, it will be 1, 1, 0, 1. So this is the answer. Understood? This is the answer. 1, 0, 1, 1. This is the answer for minus 5. So minus 5, 2's complement representation is this one. Okay, so it is different from sign magnitude and 1's complement representation also. Right? Then what about this minus 7? Right? So minus 7, we'll do this one. So plus 7 we know 0, 1, 1, 1. Right? 0, 1, 1, 1. So just take 1's complement of this. So it will be 1, 0, 0, 0, add 1 plus 1. Okay. Right? Just take 1's complement, then add 1. So it will become 2's complement. So it will be 1, 0, 0, 1. Right? So answer is 1, 0, 0, 1. This is the answer. Minus 7 in 2's complement representation. Understood or any doubts? Such questions may be there in your question bank. Na? You just check, may be there. Right? Just go through the your objective question bank also. If you have any doubt, please please message me. Right? I'll clarify in the next class. Okay. So this is your sports complementary. Any doubt in this? Any doubt? Okay. Next is how to do subtraction using 1's complement and 2's complement. Okay. So next we'll discuss subtraction. Okay. Before that, we'll take one question. Okay. Before that we'll take one question. So question is, it is there in your notes also. Yesterday I forwarded to you. Yes, question is, yes, question is, represent minus 17. Okay, represent minus 17 in first in sign magnitude, in 1's complement, in 2's complement. Right, this is the question. Represent minus 17, right? Minus 17 base 10 in sign magnitude, 1's complement, 2's complement. So I think it's easy. You can solve this one, right? So what you have to do? So first of all, find out plus 17, right? Plus 17, right? You know how to convert decimal to binary, right? Like this. Is this the way? So divide by 2, so it will be 2 8 just 16, right? So remainder will be 1. Okay. So 2 4 8 0. 2 4 0. 2 1 2 is a 0, right? So the answer is this one, 1 0 0 0 1. Okay. So this is the magnitude, but plus symbol is there, so we have to put 0 before. MSB bit will be 0. Okay. So answer will be 0, 0, 1. How many zeros? 1 2 3. Right? 1 0 0 1. Okay. So this is the for plus 17. Again, can you find for minus 17? In sign magnitude, first one, right, is the first one. Okay. So minus 17 will be 1 0 sorry, it's not 0. Right, just you have to change the MSB bit, right? So it will be 1 1 0 0 0 1, right? What will be the second one? You have to take one's complement. Okay, so it will be 0 0 1 1 1 0, right? Then third one, you have to take two's complement. Okay, so it will be answer will be just add one in this add one, you will get answer, right? So 0 0 1 1 1 1. Understood, right? So we have three representation for this negative number. Okay, so this is how we can find out, right? Then we'll move to subtraction. Subtraction using one's complement. Okay, so next is subtraction using one's complement. Okay, third and third and fourth. Uh, Previous example, you are asking about uh, previous example. I didn't get again. Shall I? Third and fourth means what? Third and fourth means what? Tell me. Third and fourth means what? No, no, just tell me. You got that right? Understood, na? See, first of all, so I'll take another example. Don't worry. I'll take another example. Right? I'll take another example. So, see, okay. Suppose question is, we'll take a small number, right? So that it will be easy to understand. So number is 8. Okay. So you have to represent -8 in signed sign magnitude representation, right? In one's complement representation, in two's complement representation. Okay. So this thing you have to do. So first of all, what you have to do, solution will be like this. First, you have to find out +8. And you know very well, plus means 0 and 8. 8 means binary representation is 1 0 0 1, right? Then this is the value of +8, but we have to find out the value of -8, right? So -8 in first case, this is the first case, this is the second case, this is the third case, right? In first case, -8 means just you have to change 1 here. Okay, MSB bit should be changed to 1 because it is negative. Okay, remaining magnitude should be same. Okay, what is the magnitude? 1 0 0 1. Understood, right? In the second case, one's complement case, right? In one's complement means you need to take only one's complement of +8. What is +8? You just need to take one's complement of +8, right? So take one's complement of +8. So it is one's complement. So it will be the answer. Just change 1 to 0, 0 to 1, right? So it will be 1 0 1 1 0, right? Understood? Then third case is -8 for 2's complement. Okay. So 2's complement means for this number from here we have to take 2's complement. Okay, initial number is +8. What is +8? Find out, then take its 2's complement, right? So 0 1 0 0 1. What is your 2's complement means? First one's complement. Yes, for one's complement you have to consider +8 first. From +8 you have to find out, right? From +8 you have to find out one's complement. Then for 2's complement also from +8. Right? So before going to -8, you need to first find out what is +8. Then only you can find out. Okay. Right. So 2's complement means again. So so this is the +8, right? This is +8. So its one's complement will be 1 0, 1, 1, 0. Okay. Then just add 1. Add 1 in this. So we'll get 2's complement. So it will be 1, 0, 1, 1, 1. Right. This is the answer for this one. 1, 0, 1, 1, 1. This one. Right. Understood now? Is it clear? Or any doubt in this? First of all, you have to find out plus, what is the value, then convert 1's complement, then 2's complement, right? Okay. Okay. Then we'll move to subtraction part. Okay. So we're discussing subtraction, subtraction using 1's complement, right? So what is the need for doing this subtraction using 1's complement? See, actually our computer system, right, is a digital system, right? So it does not know about the decimal number system. See, okay. See, aha, in question plus 8 won't be given. In question minus 8 will be given. Plus 8 won't be given in your question. Your question will be like this. See, your question will be given represent minus 8 in 1's complement form, right? This is your question, right? So first of all, you need to find out what is plus 8. Then you can find out minus 8, right? In your question, it will be asked for minus 8, not for plus 8. If it is asked for plus 8, simple. Plus 8, you know, right? Plus 8, how to write the plus 8, you know, right? In your question, it will be asking for my negative numbers only, not positive numbers. Positive numbers same as we know, right? Right. Just a minute. 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 Okay. Right. Yes. Right. So we are discussing subtraction, right? Subtraction using 1's complement. Using 1's complement, right? So already we know how to do subtraction of binary numbers. What is the rule? The rule is 0 minus 0 is equal to 0 with borrow 0, right? This is subtraction part. This is borrow part, right? Then 0 minus 1 is 1 with borrow 1. 1 minus 0 is 1 with borrow 1. Not. It's a borrow 0, right? So 0 minus 0 is equal to already, right? 1 minus 1 is equal to 0 with mistake, right? This thing already we know, right? This thing already we know. So in our digital system, what happened? It deals with binary numbers, right? In your system, computer system, it deals with binary, that is machine language. Machine language only knows 1 and zeros, right? It doesn't knows about other systems, that is your decimal systems, right? Whatever input will give, that will convert to binary system, right? Then it will process, again it will convert to decimal to binary, it will process there, again after getting the result it will convert to decimal, and it will show in the display board so that we can see, we can identify, right? If the results, if you're in your calculator, if the results will come in binary number, is it difficult for you to recognize what is that number, right? If it comes in decimal, so it's we are comfortable in decimal, right? So that is called high level language actually, right? The user, the language in which the user is comfortable, that is called high level. The system is comfortable, that is called low level, right? So what exactly happens while doing the subtraction, binary subtraction in the system, it will be little bit complex for the system, right? Complexity will be there, right? So in order to reduce, in order to remove that limitation, right, we are going for this ones complement and twos complement subtraction. Here, no need to do any subtraction. Only the operation is required, that is the addition. Okay. The operation is needed to do is only addition. Through addition, we can do subtraction. Okay. So the basic logic behind, or the basic motto behind this ones complement subtraction, twos complement subtraction, or even nines complement and tens complement subtraction is, through addition we can find out the output, right? Subtraction will do through addition. How? Right? So this is the main thing. So we are going to discuss that thing. First is subtraction using ones complement. Okay. So we have certain steps. You need to remember those steps, right? Through an example, I will explain. Okay. The theory part is there in the notes. No need to write here again. You just go through the notes. Whatever I'll discuss today, just after the class, please do revise them. Take some numbers. You do revision so that it will be easy to understand, right? Okay. So question is, I'll take simple number first. Question is 7 minus 5, right? Find the value of, or subtract 7 minus 5 using ones complement, right? Using ones complement. So what to do? What are the steps? So step number 1, right? Step 1. Step 1. First of all, find out, right? I'll take this one is, this is the first number, this is the second number, or this is the minand and this is the subtrahend. You know about this, right? Let the second number, right? In step 1, what you have to do, you have to convert ones complement of the second number, right? What is the second number? Second number is 5. Okay. So first of all, what you have to do, you have to find out the ones complement of the second number, right? If you find out ones complement of the second number, already we discussed, ones complement of any number is the negative number. Yes or no? Right. So if we take ones complement of 5, then it will be minus 5. Right. So what is 5? 5 is 0, 1, 0, 1. Right. So I'll take step 1. I'll take ones complement of second number, that is 5, right? Ones complement of 5, it will be equal to 1, 0, 1, 0, right? Understood? Right. So that also you can take like this, 101 also you take, no problem, right? You can take for 5, it is 101. We are representing in 4-bit number, that's why I'm writing 0101, right? Because left hand side, I think 0 has no value. Okay. So you can write like this also, right? Okay. We'll do like this. Ones complement of 5 is 1010, right? After that, what you have to do, right? This is the step 1. In step 2, just add first number with ones complement of second number, right? So this 7 minus 5, can I write like this? 7 plus minus 5, can I write like this? So I'm doing this one only, right? I'm representing minus 5 into some numbers, binary numbers, and I'm doing addition, right? 7 plus of minus 5. Okay. So in step 2, you have to add. What you have to add? You have to add the first number with the ones complement of the second number. Okay. So first number is 7. 7 means, what is the binary equivalent? Is a 111. So 0, 1, 1, 1. Okay. Plus second number is, right? You have to do addition like this, right? 0, 1, 1 is the first number. Second number is 1, 0, 1, 0. Okay. So do add. Yes. So 1 plus 0 is equal to 1. 1 plus 1 is equal to 0 with carry 1. 1 plus 1 is equal to 0 with carry 1. 1 plus 1 is equal to 0 with carry 1. Right? Like this, you have to add these two numbers, right? After that, you have to check whether there is a carry or not. This is called final carry, right? After addition, whether there is a final carry or not. Is there any final carry? Yes, there is a final carry, right? If there is a final carry, then you have to neglect this one. You have to neglect this one. right? What you have to do? You have to add this one with the LSB. This is the rule. You have to remember these steps, right? You have to neglect and you have to add to the LSB, right? Just do the addition again. You have to add here, right? So 1 plus 1 is equal to 0 with carry 1, then 1, then 0, then 0, right? Now this is my answer. This is the answer, right? So obviously we don't want our answer in binary. We want our answer in decimal. So convert this binary to decimal. So 0010, what is the conversion? Decimal conversion is a 2. Yes or no? So this is the answer. This is the answer in binary. This is the answer in decimal. So we'll do checking here, right? Whether my answer is correct or not. So in checking, what is the question? Is it 7 minus 5? And what you are getting? 2. Is it correct? This is correct. This is how you can find out you can check your answer also, right? This is the case if carry is generated. If there is no carry, we have another step also. If there is no carry, okay. By this time understood this one. If there is a carry, then you have to follow this process. If there is a carry, understood this one, right? If there is a carry, then you have to go like this. Steps are written in the notes. Please go through the notes after the class, right? We'll take another example where carry won't be generated or there will be no carry, right? We'll take another example. I'll do the reverse. 5 minus 7. Okay, I'll do the reverse. 5 minus 7, right? In this case, see, same steps. So for second number, I have to find out the ones complement, right? So first number is 0, 101, first number for 5. For minus 7. Minus 7 means I have to take ones complement of 7. So 7 is 0, 1, 1, 1. Ones complement of this one is equal to 0, 0, 0, 1, right? So minus 7 directly I can write here 1, 0, 0, 0. Understood? So you need to add this 2. Step 3, addition. So 1, 0, 1, 1. Is there any carry? No carry, right? If there is no carry, means your answer will be in negative, right? Your answer will be in negative. What will be then your answer? Then what you have to do, just convert it into ones complement. So ones complement will be 0, 1, 0, 0, right? Now this is your result in binary. This is your result in binary. But you don't want binary, you want to answer in decimal. So what is the decimal conversion of 0010? It's a 2, right? So your answer will be negative of 2. Is it correct here? Can you find 5 minus 7 is equal to minus 2? Is this correct? You checked here, right? Understood? This is the case. You have to remember the steps. It's very easy only, but you have to remember. If carry is there, neglect that carry, add that carry to LSB, right? After addition, convert to decimal. If carry is not there, the answer will be negative, and whatever after whatever summation result you get, you have to just convert into decimal. That is the sorry. You have to take the ones complement and convert to decimal. These are the steps for ones complement subtraction. Is there any doubt? Ones complement subtraction. Some examples are discussed in the notes. Just go through those examples.